Prior to the introduction of the T160, all Tridents were fitted with 3/8" triplex primary chains. The chains for these earlier T150 designated models are still readily available. Later T160 Tridents had a little less room in the primary chain case because of how the gear lever was relocated to the left-hand side. The designers chose to use a 7/16" duplex primary chain to create more room. Unfortunately, 7/16" duplex chain is no longer available, so T160 owners are faced with a problem as their original chains reach the end of their service life. Belt drive conversion kits are available, but belts break way too often. Other chain conversions are available, but none have matched the simplicity and reliability of the triplex chain fitted to the earlier Tridents. So here at Classic Triumph, we decided to see if there was any reason why the triplex chain would not fit a T160. Our goal was simple: to produce a simple swap and go conversion that required little or no modifications to any other engine components. It turned out to be easier than expected, and we have now created what is possibly the world's first T160 triplex chain conversion kit. We produced a new push drive sprocket and a slightly longer spacer for the crossover shaft gear quadrant. Here we demonstrate how easy it is to fit these in conjunction with the standard T150 engine sprocket and primary chain we sourced on eBay. Assuming you've already removed the primary drive cover, chain and sprockets and are ready to start fitting the triplex chain conversion, start by fitting the new push drive rubbers into the new triplex push drive sprocket. Using the Triumph service tool, the rubbers are fitted first on one side of the webs and then the other. The cover is screwed into place and tab washers are bent into place. The complete push drive is then placed into the primary cover with the thrust bearing and washers in place and rotated to check that it does not make contact with the gear lever shaft. If the gear lever shaft has excessive end float, a washer may be needed behind the circlip to keep the shaft from making contact with the sprocket. While most machines will not even require the washer, in one case we encountered the gear lever shaft required a tap from the inside with a hammer to slightly move the brass bush it rotates in sideways to create the required clearance. Once the clearance with the gear lever shaft is established, sprocket alignment needs to be set correctly. This is how we did it. A piece of key steel is used here as a straight edge. The push drive is pushed firmly into the outer cover, and the gap between the back of the sprocket teeth and the key steel is measured with feeler gauges. Once established, this measurement is recorded. The sprocket width is measured. The gasket's thickness is added to the sum and the total is established. Now the distance from the gasket surface to the outer face of the engine sprocket is measured. And the front and rear distances are compared. We had a 0.16mm shim, which got us to within 0.01 of a millimetre. The Trident workshop manual suggests this needs to be within 0.010 of an inch, which is roughly 0.25 of a millimetre, so we're good to go. Remove the engine sprocket and fit the shim. And then introduce the sprockets and chain as an assembly. Engage the clutch spline first and then rotate until the engine splines line up. To make sure the gear change crossover shaft quadrant does not interfere with the new wider sprocket, a slightly longer spacer bush was created. The bush is fitted and then the retainer. Bolts are tightened and the tab washer is crimped over. The spacer is fitted and the crossover shaft gear quadrant is fitted and secured. thrust bearing is fitted, fifth gear is selected, and brakes are applied. And the two securing nuts are now tensioned up using a tension wrench. A new gasket is fitted to the primary cover, the chain adjuster slipper is dropped into place, and the primary cover is fitted. The gear lever shaft quadrant is checked for engagement, and a screw is inserted to support the gasket. With a gentle shove, the primary cover is located into place. Screws are inserted and tensioned up. The chain adjuster is set and the lock nut tightened. If the chain tension is too tight without the slipper making any contact with the adjuster, removing a small amount of metal off the back of the slipper with a file will resolve this problem. Obviously check that before the gasket and screws are in place. The clutch thrust plate is slipped into position. Grease is dabbed into the ramps, and the balls are squished into the grease so they stay in position. The clutch cable is fed through the adjuster and into the chamber and engaged with the clutch lifter. This is then placed into position and held while the adjuster nut is screwed into position to hold the balls in place. When adjusted correctly, there should be no load on the pull rod, but with as little slack as possible. The workshop manual suggests 5/1000 of an inch minimum clearance, but in reality it needs to be more like 1 or 2 thou. Thrust plate springs are fitted and secured. And the inspection cover is fitted and screws are tightened. Foot peg is refitted, and the gear lever is fitted and secured. The primary chain case is refilled with 350 cc's of engine oil, and the inspection cap is refitted securely. With the job complete, the engine is started, and this bike is now ready for many more miles of great T160 riding.